A voltage doubler circuit uses diodes and capacitors to take an AC voltage and increase the peak voltage at the output. This circuit doubles the input voltage. It starts with an AC voltage source. Let's assume a 5-volt AC source. AC stands for alternating current, meaning the voltage swings back and forth between a positive value like 5 volts and a negative value like -5 volts. Capacitors are components that can store electrical charge. In this circuit, they are used to store and combine voltages. You have a capacitor with a value of 10 microfarads. Diodes allow electricity to flow in only one direction. They control how and when the capacitors charge during the different parts of the AC cycle. In the positive half cycle of AC, the voltage is positive. The first diode becomes forward biased, allowing current to pass. The first capacitor charges up to the peak voltage of 5 volts. The second diode does not conduct in this part of the cycle. In the negative half cycle, the first diode becomes reverse biased, blocking current. The second diode becomes forward biased, allowing current to pass. The second capacitor charges up to the sum of the input voltage and the voltage across the first capacitor. Since the first capacitor already has 5 volts stored, the second capacitor will charge to an additional 5 volts, resulting in a total of 10 volts across both capacitors. After both the positive and negative half cycles, the output voltage is double the input peak voltage. If the input AC voltage was 5 volts, the output DC voltage will be 10 volts. This works because the capacitors are charged during different parts of the AC cycle and their stored voltages are combined. The diodes ensure the current flows in the correct direction during each half cycle, allowing the capacitors to store and add voltages together. This circuit is a simple way to increase voltage. It is used in power supplies and other circuits where a higher voltage is needed.